This is the 5th video on differentiation. In this video we're going to have a look at using all of the skills of differentiation to actually start solving some problems. So, here's a question. We're told that f of x is the function 4x squared minus 8x plus 3, and we're asked to find the gradient of that function at the point 1/2, 0. We've got a couple of other questions that we'll come to shortly, but let's work out the part A first of all. So we want to know the gradient. That's going to require us to differentiate this function. So if I do that, dy by dx, differentiating this then, so I'll get 8x minus 8, and when x is 1/2, so if I substitute 1/2 into here, 8 times 1/2 is 4, 4 take away 8 is minus 4. So the gradient of this curve at that point is minus 4. Part B. Find the coordinates of the point on the graph where the gradient is 8. Okay, so the gradient function, the 8x minus 8, this is my gradient function, that needs to equal 8. So I've got an equation to solve now. So if I add the 8 to both sides, and then divide by 8. There we go. So the x coordinate is 2 when the gradient is 8. I just need to work out the y coordinate now. So if I substitute 2 into here, so I'll get 4 times 4, 16, minus 16, plus 3, so just substituting the 2 into the function so I can work out the y coordinate, substitute the 2 in here, and here will give me 3. And there we go. So that's part B done. Part C, find the gradient at the points where the curve meets the line y equals 4x minus 5. So where the curve meets that line. So I need to work out where those points are to begin with. So this is a simultaneous equations question, because I need to find out where these two lines are going to meet. Once I've solved that and I know where they meet, I will then know the x coordinates so I can work out the gradient with my gradient function. So 4x squared minus 8x plus 3. When does this curve meet 4x minus 5? So collecting up the like terms, and we can simplify this to get x squared minus 3x plus 2. Factorise, we have minus 2 and a minus 1. So the curve's going to meet when x is 2, when x is 1. And if I now substitute both of those into my gradient function to work out the gradient at those points, so dy by dx, that was 8x minus 8, I think. Yeah, that was my gradient function. So the curve and the line meet here, so let's substitute that in. Substituting that in there gives 16. And substituting the 1 in, so when I substitute the 1 in, I will get 0. So where the curves meet when x is 2, where the curve and the line meet at x equals 2, the gradient of the curve at that point is 16. And then they also meet, the curve and the straight line also meet when x is 1, and the gradient at that point is 0. Second example. So got curve C that has this equation. We want to find the gradient of the curve when x is 5. So, nice and simple. I want to know the gradient, so I need to differentiate this. Me 3x squared plus 6x minus 5. Substitute the 5 in. So 3 times 5 squared plus 6 times 5. What's that? So that's 75, 105, so that's 100. So the gradient of the curve is 100 when x is 5. Part B. Find the coordinates when the curve is parallel to y equals 4x minus 1. So parallel to this means the gradient is 4. So that means my gradient function, this thing, would equal 4. So 3x squared plus 6x minus 5. When is the gradient 4? Solving this then. You can divide through by 3 and factorise. So x equals minus 3 or x equals 1. And now, to get the y coordinates, I just substitute both of those back into my original function. So if I substitute 3 and, minus 3 and 1 into this, so minus 3 cubed is minus 27. 3 times minus 3 squared is plus 27. That's going to give me a plus 15 plus 1, so that's 16. And then substituting the 1 in. So if I put 1 in here and here, so 1 plus 3, 4, 5. Take away 5 is 0. So at these two coordinates, this curve is parallel to that straight line.